This is day 2 of section 2.4. I'm going to start out by finding the slope of a tangent line to the function at the origin. As a reminder, these are pretty simple. We're just going to be taking the derivative of sine, which is cosine. Now, since it's not just a plain x, we will go ahead and write the 3x, but we have to remember to take the derivative of that part. That goes back to the definition we saw the other day, that the derivative with respect to x of sine u was equal to cosine u times u prime, which meant you wrote down the derivative of the sine was cosine, you wrote what was after it, but then you took the derivative of that u. And that's exactly what I'm doing in this problem. The derivative of sine is cosine, I wrote what was after it, and then I took the derivative of that 3x. So I will rewrite this as 3 cosine of 3x, and it did say to find it at the origin, so I will plug in 0. I end up getting 3 times the cosine of 0 is 1, and so the derivative is 3. The second one of these starts out again in the same manner, that the derivative of sine is cosine, write what is after it, but take the derivative of that part, which is 1/2. I'll pull out that 1/2 again out front. So I have the derivative being 1/2 cosine of x over 2. We'll find the derivative at the origin again by plugging in 0. So I end up getting the derivative being 1/2 times 1, which is just 1/2. The second example is also another trig function. I will take the derivative of cosine. The derivative of cosine is negative sine, and I will write what is after it. Since this is not just a plain x, I have to take the derivative of that whole part. This actually requires me to use chain rule. So chain rule says I bring this out front, 2, rewrite it, and lower it by 1, which makes it have an exponent of 1. But again, I have to use another derivative because I have to do what's inside of these parentheses. So I have to take the derivative of what's inside those parentheses, which is a negative 2. So this problem has become quite complex. I'm going to walk back through that again. The first thing I did was take the derivative of cosine, which was negative sine, and I copied what was after it. What was after it was a large quantity, and so when I take the derivative of that large quantity, I have to bring the exponent out front, which was where the 2 came from, rewrite the parentheses, and lower it by 1. Since this was another set of parentheses, you have to take the derivative of what's inside those parentheses. The derivative of 1 was 0, and the derivative of negative 2x was negative 2. Really, what's left to do on this problem is to simplify this. And we do want to simplify this. I will underline what I'm going to put together. So I'm going to put together the negative 1. I'm going to say I have negative 1 times 2 times negative 2, which gives me a positive 4. I'm going to bring this 1 minus 2x out front. And then I'm going to rewrite the sign of 1 minus 2x squared. This is as far as I'm going to simplify this. You could distribute, I guess I will take it just one step further. I could distribute this 4 through and finish it to make it look like this.